All right, Pirates, what we're going to do today, we're going to go over the test we just took last week. We're going to start with part 1, questions 1 through 7. As we go through this, if you're missing anything on yours that's not written down, go ahead and write that down now. Also, following with all test taking strategies. So as I mark something of what it's asking us, make sure you mark that. And what information is given to us, we mark that also. All right, let's start with question number 1. A graduated cylinder and a balance are used to determine the density of a mineral sample. The mineral sample has a volume of 64 centimeters cubed and a mass of 160 grams. What is the density of this mineral sample? Record your answers and fill in the bubbles in your answer document. Be sure to use the correct place value. All right, so first thing I want to do is see what is it asking for. It says, what is the density of this mineral sample? It's asking us for density. Oops, wrong button. It's asking for the density, right? Once you see density, you want to write down the density formula. Density equals mass over volume. You also want to do the triangle. I'm going to draw my triangle. And I'm going to fill it in. So I see D is on top, V is on bottom. On our formula, so same thing here. Mass on top, volume on bottom. So left over is the D. Now let's draw a blank one, so that's what we're going to fill in. All right, so what information does this question give us? So the mineral sample has a volume of 64 centimeters cubed. So we're given a volume and a mass of 160 grams. All right, just plug in those values we're given. So the volume is 64 centimeters cubed, put 64 on the bottom, and a mass of 160 grams. 160. And we're looking for density. We have no idea what it is. So let's plug in the calculator. 160 is on top, 64 is on bottom, so we're going to divide. So we're given a calculator on the STAR test. Let's use those today. So 160 divided by 64. Enter, and I'm given 2.5. So density equals 2.5. And that is our answer. So we should be filling in this on our bubble sheet. Let's go to second question number 2. Hurricanes develop over the Atlantic Ocean waters, while these tropical storms are called typhoons in the northwestern Pacific Ocean and the southeastern Indian Ocean and southwestern Pacific. These are referred to as cyclones. What role do oceans play in the formation of those weather systems? So it's asking us, what role do oceans play in the formation of these weather systems? Information is given to us in number 1, high pressure conditions, 2, high heat source, 3, low pressure conditions, 4, high salinity conditions. And the questions are given to us as oceans provide 1, oceans provide 1, 4, oceans provide 2, 3, and oceans provide 1, 2, and 4. So we have these 4 items here. You gotta figure out which ones are correct. So let's go through each one. So high pressure systems. See, hurricanes don't like high pressure because high pressure is high. It's hot, happy weather. Hurricanes do like hot, but they don't like happy, clear skies. They need to be raining outside. So high pressure systems is not right. High heat source. So they need warm oceans. We know that. Warm is hot. So that is good. That does not look great. Let's redo that. All right, they need low pressure conditions. Yeah, remember, low, lousy weather. I mean, it's not sunny outside when it has a hurricane, so we need that low, lousy weather. Low pressure, yes. And high salinity conditions. Salinity means salt. I don't think hurricanes really care about salt. That has nothing to do with it. They just need low pressure and warm ocean currents. So let's get rid of that. So let's see which ones it matches. A, oceans provide category 1 only. Well, 1 is not the right answer, so mark that out. See, 2, or B, oceans provide 1 and 4 only. But we know those are both wrong, so that is definitely out. See, C, oceans provide 2 and 3 only. Well, both of those are looking good, so let's put a line next to it saying come back to that. And D, oceans provide 1, 2, and 4 only. We know 1 is no good. That's definitely it. So the process of elimination, we know C is our correct answer. Looking for C. All right, let's move on to the next one. The jet stream is a global pattern of atmospheric movement that influences patterns of local weather. Based on the information provided in this weather map, which city shown most recently experienced a drop in temperature? Just asking us which city recently experienced a drop in temperature. So drop is a key thing, it's underlined. Okay, so look for which city. We're given A, Reno, B, Amarillo, C, Detroit, D, Orlando. Just look at this map. So we have a current going through here. Okay, that's our warm ocean current. We have a cold front here. Cold front. That's right here. And a warm front. Right there. So we know that these little hash marks or daggers or arrows, whichever one you want to call it, they face in the direction it's moving. So this cold front's going this way. Let's change that color up. It's a cold front. Let's make it blue. So cold front's going this direction. And this warm front is going this way. All right, so which one is most recently experienced a drop? That means it's already cold. It just happened. So not in the future, but in the past. So let's take a look at those. A, Reno. See, Reno is right here. We just see the cold front just passed it, so it's probably going to be Reno. Probably. But just to make sure that's the best answer, let's go through each one. See, Amarillo. See, Amarillo is right here. The cold front has yet to reach it. But maybe got hit by the jet stream, but it's above it, so that's not it. Let's look at Detroit. Well, Detroit is about to get that warm front. I don't think it's going to be Detroit. And Orlando, well, they're sitting on top, right above that jet stream, and getting that warm air, so that's definitely not it. So it looks like we're looking at Reno. Check A, Reno. All right, let's move on. We're on a roll. Ooh, another jet stream. The jet stream is a global pattern of atmospheric movement that influences patterns in local weather. It is represented on the map below with arrows. Based on the information provided in the weather map, which city shown most recently experienced a temperature rise? So beforehand we had a drop, I'm looking for a rise. So which city experienced a temperature rise? All right, so let's look. We got a, let's change the colors again, why not? Warm front. It's right here. We got a cold front. It's a word looking F. Let's fix that F. That is right there. We know the arrows face, the triangle's facing the direction it's going. All right. So we have Albany, Bismarck, Nashville, and San Diego. So let's see which one is the correct answer. Albany. Let's see, where is Albany? Albany is right here. Let's see. We're looking for a rise in temperature. So we have a warm front going up this direction. It's probably not Albany. And they're on the jet stream. They just haven't experienced it just yet. They just didn't experience it. Because they just had that cold front also just pass them, so it's probably really cold. See, Bismarck. Where's Bismarck? Bismarck's right here. They're about to get warm. They haven't experienced already. They're about to. Definitely not Bismarck. About Nashville. So where's Nashville? Nashville's in Tennessee. They're about to get hit by a cold front, so no. We have San Diego, California. Right here. They already had the warm front pass them. Warm front went up this way. So they're already nice and warm. So it looks like San Diego is our choice through elimination. Question 5. Ooh, we've seen this one before. Earth's land, oceans, and atmosphere maintain fairly constant average temperatures. What is the best explanation for these constant average temperatures? So looking for what's the best explanation for constant average. Once we see constant average temperatures, we can start thinking of, draw it, convection. Warm air rises, cold air sinks. And also goes along with water too. Warm water rises, cold water sinks. So let's look at each of these choices. A, Earth is tilted and rotates daily on its axis. That is true, but does not explain why constant average temperatures, or does not explain the constant average temperatures. So no. B, Earth's northern hemisphere and southern hemisphere have opposite seasons. That is true, but it does not ask on the question. We're asking about convection, not about seasons. C, global weather systems generally move from west to east. Again, true, but that doesn't explain convection. Then D, the convection currents of air and water distributes the sun's energy. So you're seeing convection currents, what we have right here, convection currents, and distributes the sun's energy. So the sun shines on the earth, heats the water up, and that's what makes it move. It's like the light bulb on our, what do you call that thing? The lava lamp. As it heats up the lava on the lava lamp, it goes up, as it cools down, it goes down. Up and down, over and over. It's the convection. So D is our answer. Let's move on. Let's get rid of that line. As part of a homework assignment, Katrina collected and recorded observations about weather for several days. Data is shown in the table below. Based on this data, what weather event occurred between Tuesday and Thursday? Okay, so what occurred between Tuesday and Thursday? You see on Monday, it's rainy. Tuesday, cooler and cloudy weather. Wednesday, hot and cloudy. Thursday, hot and clear skies. For Tuesday and Thursday. So let's just little bracket. We went here. Not about Monday. We can care less on Monday. All right. So A, cold front passed through the area. Let's see. So it's cooler and cloudy, then hot and cloudy. Let's see. So cooler and cloudy. No, hot and cloudy. So probably had a high pressure hitting there, or a warm front. So that's probably not it. A low pressure system is in control of the weather pattern. If it's hot and cloudy, probably have a high pressure, not a low pressure. C, a warm front passed through the area. Let's see if it got hotter, was cool, and it got warm. Possible. Put a line next to it. See, it's a good choice. D, a warm front stalled over the area, controlling the weather pattern. No. Looks like our best choice would be C. The reason we wouldn't say it would be stalled, because if we look at, it says hot and cloudy on Wednesday, and Thursday it's hot with clear skies. It did change. If it's stalled and controlled it, then it'll be the same on both. In this case, it just passed through. So it's C. All right. Last one for part 1. In 2011, Typhoon Nesat struck the Philippines and caused a widespread flooding after hitting the Philippines. Typhoon Nesat was predicted to hit the large city of Hanoi, Vietnam. Let's take a look at this map here. So we have a hurricane following on right here. I expect to hit Hanoi. All right. So we see the dotted line is the predicted. This is the predicted right here. And this is where it's already been. The solid's where it's already at. Okay. Let's go to each one. If the Typhoon Nesat continue along the same path, which development would most likely have reduced its strength before hitting Hanoi? So we're trying to figure out which development would have likely reduced the strength before hitting Hanoi. Let's go through each one. A warm water moving in the southeast into the southeast of Hanoi. All right, so do like a little compass rose here. This is north, south, west, east. So southeast, warm water in this area here. Remember, warm water makes it stronger. So definitely not that. So just mark you out. Remember, warm water strengthen it. We went to weaken. It's going to weaken it or reduce its strength. let's see, cool water moving into the southeast of an eye. So southeast is over here, cold water. So we put that cold water right here. Remember, cold water makes hurricanes sad. They start dying off. They need that warm water to live. So it looks like we might have it right there. Let's check out the others. The formation of low pressure in the south of Bangkok. Bangkok's over here. If we have low pressure, that's nowhere near the hurricane, so I don't think it really cares. That's a formation of high pressure south of Bangkok. Same thing if we have high here now. The hurricane could care less. So I'm left with one option. The cool water. All right, now this time go ahead and pull out part 2 of your test, and we'll start covering that.